If you've ever looked up at power lines, you might have noticed long strings of round, plate-like objects hanging from the cables. They almost look decorative, like a necklace made of oversized beads. But these discs are far from ornamental. They're high-voltage ceramic insulators, and they perform a critical role, keeping massive amounts of electricity safely suspended above the ground. Without them, our cities, hospitals, factories, and even your phone charger wouldn't work the way they do. Their disc shape might seem unusual, but it's the result of over a century of careful engineering. Today, we're going to explore why these insulators have discs, how they manage dangerous electricity, and why this design has stood the test of time. Right here on History of Simple Things. In the early days of electrical power, the main challenge was keeping high-voltage current from leaking into poles, buildings, or the ground. Telegraph and telephone lines use simple glass or porcelain knobs attached to wooden poles, which worked fine for low voltage. But as electric power stations began sending stronger currents over longer distances, these early insulators often failed. Electricity would leak, spark, and sometimes even cause fires. By the early 1900s, engineers realized that larger, more reliable insulators were needed. This led to the development of porcelain suspension insulators made of individual discs connected in chains. Rather than using one massive insulator, multiple discs could be linked together, creating a modular system that could handle increasingly high voltages. First widely adopted in the United States and Europe, this design proved so effective that it became the global standard, and it's still in use today. A ceramic disc insulator is typically made from high-quality porcelain, sometimes toughened glass, with metal fittings on both ends. These fittings allow the discs to be connected into a hanging chain, called a suspension string, between the power line and the supporting tower. Each disc is designed to block electricity from traveling where it shouldn't. Porcelain is naturally resistant to electrical flow, dense and heat-resistant. Its glazed surface helps prevent moisture or dirt from creating conductive paths. When multiple discs are connected, they allow the power cable to hang safely, keeping dangerous voltage separated from the structure and people below. It might seem simpler to use one large insulator, but multiple discs offer major advantages. Each disc can handle a specific amount of voltage, so connecting more discs allows engineers to safely manage higher voltages. For example, if one disc insulates around 11 to 15 kilovolts, a 200 kilovolt line can simply use a string of enough discs to handle it. This modular system is also practical for maintenance. If a disc is damaged by lightning, pollution, or aging, it can be replaced individually without shutting down the entire line. A single large insulator would require complete replacement, which is costly and time-consuming. The round, plate-like shape of these insulators is designed to control electricity in the air. High-voltage electricity doesn't only travel through wires, it can leak along insulator surfaces if conditions are right, a phenomenon called electrical flashover. The disc shape increases the creepage distance. The path electricity would have to travel along the surface. Longer paths make it harder for current to escape. The shape also helps water management. Rain naturally drips off the curved edges rather than forming a continuous conductive path. This is essential in foggy, polluted, or wet environments, where electricity could otherwise find an unintended route. Power lines face heat, cold, wind, salt from oceans, industrial pollution, dust, and even bird droppings. Ceramic discs are fired at high temperatures, making them tough and resistant to cracking. Their glazed surfaces resist chemical damage and make cleaning easier. In heavily polluted areas, engineers may use longer strings or specially shaped discs to improve performance. Mountains, coasts, and industrial cities all present unique challenges, and the number or type of discs is often adapted to the environment. This flexibility is one reason the disc design has endured for over a century. Today, some power lines use polymer composite insulators made from fiberglass and silicone rubber. These are lighter and sometimes cheaper. However, ceramic disc insulators remain popular because of their proven lifespan, often 40 to 70 years. They resist ultraviolet light, extreme temperatures, and aging. Another advantage is visibility. Cracks, damage, and contamination are easier to detect on ceramic surfaces. This makes inspections more reliable, which is critical for high-voltage infrastructure. Even in a world of modern materials, disc insulators continue to be a trusted solution. The hanging chains of ceramic discs may look ordinary, but they embody more than a century of engineering innovation. Their modular design allows power systems to handle growing voltages. Their shape controls dangerous electrical forces, and their material ensures durability in harsh environments. From the earliest experiments in the 1900s to today's massive global grids, these insulators quietly protect the flow of electricity that powers our lives. Next time you see those stacked discs swaying in the wind, remember, they're not decorations. They're guardians of modern life, keeping our lights on, our devices running, and our cities safe, one ceramic disc at a time. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.